Thank you everyone for coming. We're about to get started. The first step we're going to do is start with, if you can please click on that QR code, that is going to take you to an express version of the program so you can have access to it. And you're also going to have a small pretest so that you can have a feeling as to what you will learn with the program. Whatever questions you don't know the answer to, just please choose I don't know or choose whatever and move on so you can have time to answer the questions that you might have the answer to.
Sorry, that's financial Qbits pretest, yeah?
Yeah. Hi. So if you can please use the QR code, that's going to give you access to an express version of the program.
Sorry, where do we click on this?
Yeah, so sign in.
Okay, thank you.
Mm-hmm. Is it letting you in? Okay. Yeah. So click on the lines on top. Sign in. I think so. It should let you. If not, we'll just go into the program. But it should let you.
It's still asking me for to pay. Yeah.
Uh-huh. Mm-hmm.
I have signed in.
And it's asking you to pay. It should be free. All courses, my dashboard, my account. That's your name. That's your save changes. Billing. Yeah. Okay. I'm so sorry about that. Let's go ahead.
Invalid password.
It's giving you the okay. Did you enter it?
Yeah. Sorry, I gave my email.
Okay.
Then password.
Okay.
Okay.
You need to register.
Create a new account.
Create a new account.
Oh, create a new account? Okay. Is it letting you create a new account?
So in all courses, there are multiple, like there's a demo and then there's a couple other options. So which
Okay, the course you're looking for is the one that's called Financial Qbits Financial Qbits Quantum at Quantum Innovation Summit. That's the free version that you have access to. Did you find it?
No, I've got all the courses.
Okay, and does one say Financial Qbits at Quantum Innovation Summit?
No.
Quantum Innovation, no, Quantum at Vernaville Academy. Allow me, please.
Yeah, sure.
Okay, thanks. Certified facilitator. Yes, at Vernaville Academy. Vernaville. Demo. So there's. I'm going to try something because it really should come out. Just 1 second, please. That's why, because it's a private. You should be able, if you refresh, you should be able to see it now. Awesome, thanks. Great. Rani, can you please help him? Yeah, Financial Qbits at Quantum Innovation Summit. Welcome. So use this QR code to have access to an express version of the program. And it's going to ask you to create an account. Something like that.
So should we continue for the whole thing?
Is there, allow me please?
It's loading.
Okay. The pretest, yep. Yep, so that's the license, and then you should have a pretest.
Okay.
Yep.
Can you?
Didn't a pretest come out? Oh, because you probably hit complete and continue. There, that's the pretest. Make sure that you don't hit the complete and continue button, because otherwise it's not going to let you take the pretest.
Okay.
Yeah, that's the pretest.
Okay.
Sure.
Marking
No.
complete.
No, because that's you need to click this button here. No. There.
Okay.
Yep.
Okay.
So there's a little blue button. That's what you want to click, so you can go to the pretest. Are you there? Allow me. So, enroll for free.
Okay. Cool.
Sure.
Thank you.
My pleasure. Did you find the pretest?
Yeah.
Did you find the pretest? Okay, so that's the license, I think. So after the license,
Yeah, but what does this license say?
oh, it's just
Because I'm gonna, by clicking, I'm kind of approving this license.
well,
right?
yes, but you're approving that you're not going to sell it or market it. It's a normal license. There's nothing.
Yeah, but, before signing anything, I have always need to read what I'm signing, kind of.
In essence, it's just end user's license. Were you able to log in?
I could try, yeah. I did the scan, but I think I have no connection.
Oh. Do you have the Wi-Fi information?
No.
Let me get it for you. Wi-Fi, excuse me.
It's here, right there, Wi-Fi details.
Oh, yeah, but I have, because that's probably different from the one downstairs, right? Or no? No. You passed the quick,
Yeah,
it's,
the licensing.
yeah,
Yeah.
so no, there, that button, yes.
So you must sign off here?
Yeah, like your name. Mhm. Okay. Good.
Video.
It should be before. So, can you go back? Let me see. Allow me? Because that's after. Let me see. I'm not that good with cell phones. Oh yeah, there we go. Here, hold on. I'll show you. Allow me. Would you like to? No. That's the pretest.
So where?
Here, press this one. Yep, and then your
I want to
information.
again asking.
Because this is, you already signed up for the course, and this is to sign up for.
No, already here also I did.
I'm sorry.
Okay. I will again do it.
Okay. Okay, and the pretest is 10 minutes. So, were you able to access it?
Yeah, the videos, right? So complete and continue.
No, it's before the video.
So I'm very irritating with this.
Yeah, because if you press complete and continue, then it doesn't take you to the pretest.
It brought me to those PDFs.
I'm sorry.
It took me to those PDFs.
Yeah, it's before. So, would you like to return? No, there. That's the pretest. So press the yes, yeah. It says it at the bottom, but I know that. Very good. Is it going to be possible to turn out the lights? But isn't the live streaming off because of me, right? Mhm. Once they are finished with yeah, they're doing a pretest, and they're about to be done. It's like 4 more minutes. Awesome. Are we going to have access to that video afterwards? Are we going to have access to that video afterwards? Okay, because they will have. Right, thank you. We all right, John?
Questions? I have to read in detail
Okay.
the small screen.
Can you make it bigger?
Yeah, yeah, yeah.
Okay.
Let me know, sir, when you will give me a sign, so I will.
Okay. Absolutely. You're done with the pretest, right? Yeah, no worries. Okay. So how many more minutes do you have with the pretest? How many? 6. Yeah. Okay. And you, how long do you have?
140.
140. Okay.
Wish I had a calculator
Don't you?
on the phone, but it's so hard to like.
Oh, toggle with between. If you want, you can borrow mine.
You know, I'll do it there.
Okay. And it's just the samples, just to give you an idea what it offers. So, time. Let's give. Hold on. Fuck. Let's give 3 more minutes. This is just a sample, so you can get a feeling as to what it's about. So don't worry.
Hopefully we don't have to have a score.
I'm sorry.
Hopefully we don't have to communicate our score.
Yeah, don't worry.
I got feedback on that. I finished it
Hmm.
without finishing.
Mm. Okay, we have less than 2 minutes. 30 seconds. And time. Okay, great. Thanks for taking the pretest. Yeah. So even people in business, most people fail the pretest. And that really shouldn't be, right? Because you need to understand that type of information to speak to your accountants, to understand your financial statements, etc. Because financial statements, of course, tell you the story of your business. And if you don't understand the story of your business, you don't truly understand your business. So let's go ahead and get started. Okay, financial training, entrepreneurs, business consultants, and all quantum experts and enthusiasts. This is an idea taken from a book. The telegraph was tweaked and it became the telephone. Propeller airplanes were upgraded into turbine airplanes. But this incremental approach doesn't work with profound problems. The connection, for instance, between matter and energy was not accomplished by studying matter alone and by studying energy alone. It was found by studying something completely different, which is, of course, the speed of light. By studying the speed of light, well, Einstein was able to connect two realms that in his time were apparently disconnected, and he found the link by looking elsewhere. That book is, of course, E equals mc squared, a biography of the world's most famous equation. And the point is that sometimes we have to look elsewhere to solve problems in front of us. And that's what we think about financial qubits. We think that financial qubits is an algorithm that gives us an insight into quantum computing technology, into tensor networks that allows us to understand them much better than we would otherwise. Financial qubits is do we have another clicker by any chance? This one is not. Excuse me. Do we have another clicker? Do we have another clicker? Okay. Financial qubits is a quantum-based solution that solves a high-impact problem worldwide.
Sorry,
Partnerships.
The line is reflecting on the TV.
Okay. Thank you. Okay, so partnerships and sponsors. We are partnered with Berneville Academy. That's, of course, Malak's entrepreneurship. And we have partnered with JP Morgan Chase, FIU Continuing Education, and FIU in general, and the Americas SBC, the University of Rhode Island. So the problem, what is the problem that we're solving? What is it, right? The global economy depends on the success of businesses. And yet, countless business teams lack an essential element, which is financial literacy. This problem can be fixed, but the traditional map to become financially literate is incredibly complex. It's very, very hard to wrap our heads around because that complexity takes so much time to understand. That's to understand financial statements. It takes at least one textbook, and I kid you not, one textbook, okay? And at least 1 year to understand, and believe me, that is very generous. The complexity of the traditional paradigm affects the work of entrepreneurs, executives, business owners, portfolio managers, credit analysts, business consultants, business educators, business students, and bankers. Why? Because at least part of their work is based on financial statements. We think of education as a mental lens. And if you have a fuzzy lens, you're going to have a fuzzy understanding. If you have a fuzzy understanding, your performance is going to be lacking, right? The traditional paradigm, which comes from Luca Pacioli, 1494, is one of the few things that have not been upgraded since the time of the Renaissance. Think about that for a moment. I mean, communication has changed incredibly. Transportation, not to mention. But the model that we use to understand business is the same from the time of Luca Pacioli from 1494. And that's what all the universities are using worldwide. Given its threat to the economy, the ever-growing complexities of life, and the current inflation, a radical upgrade to the fundamental paradigm to become financially literate is needed as soon as possible. This is why Qbits Solutions Research created Financial Qbits, a new pictorial algorithm that takes just 10 hours to learn. Of course, I will explain this later, but in essence, these are four connected perspectives, right? We have the perspective of the customers, we have the expenses, we have funds, that's liabilities and owner's equity, we have the assets. Assets, of course, subdivide into current assets, fixed assets, and other assets, short-term liabilities, long-term liabilities, and owner's equity, etc. That re-encodes the map from 1494. The new quantum-based solution is poised to be an important game changer for the global economy. It should provide more equity for democratizing financial literacy in the business world. So, as I was sharing, we think of education as mental lenses, and exploiting quantum technology, specifically QML, implies having better lenses and therefore, of course, better education. You can think of Qbits Solutions Research as quantum lens crafters, right, for human and artificial brains. Okay, this is a brief history of Financial Qbits. In 2013, we partnered, in 2013, Financial Qbits was completed after many years of research and development, and Qbits Solutions Research was founded. In 2017, we partnered with FIU and JP Morgan Chase to create Asia Ganancia, a successful training program based on the new Financial Qbits visual scheme. In 2021, we partnered with the University of Rhode Island to bring Financial Qbits to their business community. In 2023, Financial Qbits article was published in a high-tech magazine, which is Intersactum Vector N360. I'll explain a little bit more later. That features cutting-edge technology from around the world. And in 2024, we partnered with Verneville Academy from Dubai to spread Financial Qbits in GCC countries. That's the article on Intersactum Vector N360. He wrote on the same issue. Brian Linehan also wrote on the same issue. That's what came out afterwards. And that's when I got invited here, and that's where we are. More than 1,000 people have been trained using the new visual scheme, and most people have learned in 10 hours what would take at least 1 year with the traditional alternative. This breaks Luca Pacioli's 500-year financial paradigm and makes financial literacy more accessible than ever before. Results are based on solid empirical evidence. I don't know if you're aware of this, but Pacioli's work is considered one of the most influential works in the history of capitalism, and that's an article from BBC from 2017. Okay, table of contents. The theme is Financial Qbits, a paradigm upgrade. We will go into that briefly. 4 keys to understand Financial Qbits. Then part 1, the world line. Part 2, the quantum algorithm. 3 quantum questions answered. QML postulates and learning objectives. Then we're going to go into Financial Qbits for the business world. And a final word and the Q&A. That's our team. You know me. Lizelia Bravo is from UPOLI, scientific artist, Qbits Solutions Research. We are collaborating with Harshita Gandhi. She is a PhD student in computer engineering at Northeastern University in Boston. We collaborate with Rani Nayar, and she is a QML coder and QSR quantum algorithm simulation project expert. And this is, of course, Rani. Okay, and that's the rest of our team. How come my voice changed all of a sudden? puberty, I guess. So is financial qubits a paradigm upgrade? Can I go to the other side of the screen, like there? Yeah, okay, great. Okay, so is it a paradigm upgrade? Okay, well, yes, we already spoke about this, right? And it has been proven to train in 10 hours what would take at least 1 year with the traditional paradigm. Except that the clicker doesn't work. No, don't worry. In the quantum world, we have a completely pictorial, minimal complexity tensor network that maps out the optimal paths for information processing, which requires only a very small training data set. And we're talking about not atoms, but we're talking about real life interactions, real 3D world interactions. Okay? So here we go, Schrodinger's cat hacks financial literacy, proudly presenting the first useful and usable by all commercial application of quantum computing technology. Based on the paper, deep learning by a unitary tensor network algorithm provides hyperfast financial literacy. Okay. Premise. Achieving quantum supremacy is not only about the hardware. To achieve it, we need to first optimize the computational efficiency of our algorithms so that we can make use of the hardware that's available today. Note, we're first going to go into the four principles, and then we're going to dive into the components of the algorithm, then into the algorithm itself. Okay, first key, the wave function. Okay. I'm not going to go into every detail as to what a wave function is, but I will explain the essence. So you can think of a wave function as a catalog containing all probable outcomes in a state of superposition within a finite framework with quantum properties. Quantum systems are expected to be able to simulate systems of the natural world of 3D events. This implies isolating a complex system, that is a system with many, many interactions in a nutshell, and representing it with a wave function, a catalog which would encode all probable outcomes for any given period of time. If you know the wave function of a system, you know everything about the system. That's what a wave function is about. But there is a problem. Wave functions can be extremely complex, and this, of course, taxes learning and computation for human and artificial brains, and that implies more hardware, and more hardware means more money. What is the solution to wave function complexity? The solution is the second key, tensor networks. So it's like if we have two options. We can learn a complex system with equations, code, and text, or we can learn it with a tensor network in which we have the superclusters, the clusters, the nodes, and that's the ground state, what we can think of the mesostate, and the excited state. It goes from abstract to concrete. That is a multi-state wave function. Tensor networks simulate complex systems by providing a graphical representation of the alphabet of the system in a hierarchical structure, which encodes all combinatorial elements from abstract to concrete. And that's important, combinatorial elements. So it's not all the answers. It doesn't contain all the answers, because then that would make it super complex. It contains only the combinatorial elements to recreate the answers. Does that make sense? That's part of what makes it so efficient, the combinatorial elements. Okay. So this formalizes the system because it reduces it to its basic truths or axioms, providing a more intuitive and visually understandable representation of the system as a whole. Okay? Notice that this structure can be thought of as a phase transition diagram. If you're not familiar with a phase transition diagram, for instance, a phase transition diagram is H2O, in which you would have ice, you would have water, and you would have vapor, right? That's a phase transition diagram. In other words, going from simple, more global features to more concrete features which are more complex. Okay. Given that third key, tensor networks are the ideal computational resource, given that tensor networks encode the combinatorial elements of a system at different layers of abstraction, they provide a funneled computing approach that reveals the optimal paths to solve problems. Their minimal complexity, hierarchical structure, provides quick elimination of superclusters, clusters, and nodes to find the right answer faster, and that translates to ultra-fast computation. So, in other words, think of it this way. If we know that the answer is this, we automatically know that the answer has to be here. And we know that the answer has to be here. And we can eliminate all other probabilities. Does that make sense? Does that make sense?
Could you repeat it? My apologies, I just myself.
Sure. So I'm saying that tensor networks go from the more abstract, the more panoramic, to more concrete, right, to the details. They have a structure. It's not all the answers or all the combinatorial elements in just one phase diagram, right? No, you go and you have from abstract to concrete. So, given the tensor networks encode the combinatorial elements of a system at different layers of abstraction, they provide a funneled computing approach. So let's say that you know that the answer is this one. Because you know that, we can eliminate all of this. And because of that, we can eliminate all of this and all of this.
So you go from an uncertainty where you eliminate very quickly the major part, and you focus down with more and more accuracy.
Exactly. That's the idea. And that's what makes it faster to compute. Okay, so a single layered wave function would not be as efficient because, as a tensor network, because you would need to search through so many more answers, as all answers would be concentrated on just one layer. Okay. Fourth key, the word line. I don't know if you're familiar with word lines, but I'll briefly explain what a word line is. Well, at least from this perspective, sum of 3D events or nows equal a word line. The accumulation of 3D events in sequential order forms a 4D story, which we can refer to as a word line. And by the way, this is just because we're doing this presentation. This is not part of the course per se, but this is a way that if you understand this part, that's going to make everything easier. Okay? So note, the word line normally refers to the trajectory of a particle, which is true at the macro scale. And that's an example of a word line. Okay. Instagram, do we have at least a basic grasp of these 4 keys? Make sense so far? In a nutshell? Yep. Yep. Okay. Yes?
So maybe word line is just like a path in space-time. So how does the relativistic concept become quantum mechanical?
Okay. Because the relations on the these relations are the nows that make up the word line.
I'm not convinced. I'll have to look at it more deeply.
Okay, absolutely.
Can you repeat, please?
Yeah, so these relations, like, okay, let's say that we're doing a transaction, right? You're selling me something, and I'm giving you $1. When I'm giving you the dollar, you take the dollar, like if they take a snapshot, that's one now.
Yep.
The accumulation of nows would give us a word line.
Okay.
Yeah, the word line is normally referred to as the trajectory of a particle in 4D space-time, right?
Yeah, it's just a path in space-time diagram.
Exactly. But this breaks it down into nows.
So the nows are the epochs.
Are the what?
Epochs. They call it the epoch. E-P-O-C-H.
I don't know what you mean by that. Yeah, the nows are the components of the word line.
Yeah. It's
Yeah.
called an epoch. Technically, it's called an epoch. Yeah.
Got it. Okay.
Yeah.
Thanks for sharing. Okay. I don't expect you to or anyone to understand this like at first glance. It takes time to, yeah. Okay. So, financial qubits, part 1, what do you know? The word line. Let's start from the beginning. What is a business, right? And I'm not asking, of course, for a dictionary explanation. I am asking, if we were to draw a business, what would it look like? What would that drawing look like? And that drawing would look like this. Because in a business, you have someone who's investing wealth into the business, and that person of that group of people, they expect to have a return on whatever they invest. So the nows would make up this world line. This is the past, and this is the future. This is the beginning, and this is the end. That's, in essence, what a business would look like from a macroscopic perspective. We can think of a business as a flow of wealth that begins with an investment, event A, the bet, and ends with the gain of this investment in event B, the gain. This flow of wealth forms a story that we can refer to as a world line. It follows a curved path because at the end of each period, there is a checkpoint, right? Like at the end of a year, you see the financial statements and you say, how did we do? Should we bet again or do we withdraw? Well, we did pretty good. Let's bet again. So we bet again. We did pretty good. Let's bet again. And we bet again. And it goes on and on and on and on as long as you have the business. Okay. Notice that each complete cycle in the story is one scale-free period of time. So it can be 1 month, 1 quarter, 1 year, it doesn't matter. And I don't know if you're familiar, but this is consistent with Mach's principle of a purely relational or background independent system. The financial story of a business is made up by individual financial events, or nows, that occur at any given instant of time, like a cash sale, or a purchase of inventory, or obtaining a bank loan, just to name a few of the possible events that could happen. The nows are sender, receiver, base pair units, where Alice sends an amount of wealth to Bob, the receiver. These base pair units are the Lego bricks of financial information. Therefore, these events are the basic building blocks of all financial statements, right? You always have that, those transactions. Wealth coming out from one pocket and going into another pocket. That's what it essentially boils down to. Whether it's a cash sale or whatever it is, you always have these transactions, and that's what make up financial statements. Does that make sense so far? Yep, okay. Could there be a wave function or catalog of all probable financial transactions to help us understand financial statements? Of course, otherwise I wouldn't be here, right? There. I'll explain in more detail, but essentially that represents the basic subset or the basic set of probable double entries from a panoramic perspective. If you understand those 12 double entries, you understand a business. You can decode the story of a business by understanding those 12 relations. Okay. The wave function on the right gives us the set of all probable outcomes and therefore all probable 3D events that can occur within the world line on the left. Okay? Therefore, we can say this, we can slice the world line into these nows. Does that make sense? Great. So there's the world line at the left, and these are the nows on the right. So let's go. Transactions. Okay. Financial statements are the reports that tell us the condition of a business's world line for any given period of time. Double entries are the atoms that populate them, right? Double entries make up financial statements. They are the Lego bricks of financial statements. Part 2, the quantum algorithm. We're going to kind of like see the same thing, but from a different perspective. Why is it important to understand financial statements? Well, financial statements tell us the story of a business. Understanding the story can help businesses grow and succeed. The story of a business is made up by discrete units, as I shared before, double entries. Like, let's say the owners of the business make a contribution, so that would be an outflow from owner's equity, and it would be an inflow into cash. Or if we make a cash sale, it would be an outflow from the customer's pocket. That's what sales really represents, the customer's pocket, and it would inflow into the business's pocket in cash. Double entries are sender-receiver base pair units, where Alice, the sender, sends an amount of wealth to Bob, the receiver. Double entries are the building blocks of financial events, like a cash sale, a rent payment, or getting a bank loan, etc. Well, then you might say financial literacy is simple. We just need to learn the set of all double entry transactions, and we're going to be financially literate. Well, no, it's not that simple, because double entries are infinite. Double entries are infinite, and infinity means chaos. If you have infinity, there's not much you can do with it, and that's why we have such big textbooks to learn the information, because the double entries are infinite. Okay? This explains why Pacioli's model from 1494 is monstrously complex. To create financial qubits, double entry infinity needed to be quantized down to a ground state or minimal complexity level. So that means getting all those double entries and quantizing them down to the minimal complexity level. How? Well, by condensing nodes, in other words, accounts, into clusters of nodes. So, in this case, all of these, for instance, are liabilities that we have to pay within 1 year. So those are short-term liabilities. These liabilities we have to pay in a period longer than 1 year. And these liabilities, right, because capital stock, what the owners put into the business, there is a liability with them. It's not as if they're just putting the money there just for fun. That's the time period is indefinite. So we can say this: short-term liabilities, long-term liabilities, and owner's equity. All of these, current assets, fixed assets, other assets, current assets, fixed assets, other assets. Local sales, non-local sales, etc. And the expenses are encoded like so. Condensing clusters into superclusters.
Excuse me.
Yes, sir.
Can you go back before you have all the color diagram?
Yep.
You've arranged all these things in a way that fits the square.
Yes.
So the question is, how did you arrange it? Because is it you who did so? In which case you've already given the basics for what you're now currently doing, or how did it occur?
Okay, well, yes, we realized this took 2 generations, right? So our father realized that all the accounts of a business boiled down to just 4 accounts.
Okay.
If you ask an accountant, they would say that it's 5 accounts, because they would say sales or revenue, expenses, assets, liabilities, and owner's equity. So that's 5 big accounts. My dad realized that you can condense liabilities and owner's equity into one, which is funds. And then by doing so, everything got condensed. And right now we're looking at the sectors, and now we're going to look at we're looking at the clusters/sectors, and then we're going to look at the superclusters, which condense the clusters. Okay. So there, and there. So condensing clusters into superclusters. So short-term liabilities, long-term liabilities, and owner's equity. What are those? Those are sources of wealth that finance the assets. So we can all call them funds. Funds. Current assets, fixed assets, other assets, assets. Sales, expenses. I'll explain more later, and it's on the app. Finally, by condensing higher dimensional vectors, 3D, into lower dimensional tensors, 2D. So we convert these transactions from the everyday world of 3 dimensions into a 2-dimensional encoding. This encodes the double entry field within the bounds of a 12-body tensor network, providing a minimal complexity visual alphabet that is much easier to grasp than the textbook's worth of information from the traditional model. Note, given normal dynamics, this is the metric signature of polarity of this tensor network. This provides all the necessary combinatorial elements for the search space of a quantum algorithm to learn and process financial statements information in a hyperfast way, because we can reconstruct any probable double entry, okay? The pixels. Okay, let me not block the screen. The financial wave function factorizes the pixel of this field, which is, of course, the double entry, which spans from its unobserved state to its learned/observed state, right? It goes from here, the unobserved double entry. This is a ground state of the probable outcomes. This is what we can refer to as a mesostate. And this is the excited state, those would be the actual double entries, right? So this is more abstract, and it goes to less abstract and more concrete. Once we gather all the information, then we have the observed or learned double entry, because it already picked up all the information that needed to be picked up. Yes?
Sorry to be asking so many questions.
No.
The second hidden layer, it's obviously an intermediate layer. How do you decide where the intermediary layer is in this process? I mean, obviously for us it's very simple because we know what the system is and it makes sense. But if you're not sure, how do you build this up?
Well, I mean, this is the most efficient structure that we were able to formulate.
Yeah, but if you take this problem to something completely different that you've never come across,
okay,
where you haven't spent a long time thinking about it, would you be able to build these layers up?
That's a wonderful question. And something that happened recently is that, so this is about financial accounting, right? This is about understanding the fundamental map, which are the financial statements. That's not the end of the story, because then it's about financial management. And we recently created a financial management map. And thanks to understanding this structure, we were able to do the other structure. Does that make sense? Yeah. Okay, great. And by all means, I mean, feel free to ask questions, because that's what we're here for. Okay, so this is multi-phase wave function / tensor neural network / a phase transition diagram that equals the combinatorial elements to recreate all real-life financial events that populate financial statements. This is, you can think of it as a quantized hierarchical categorization. Okay? Okay. The factorizes the pixel. Oh yeah, so that's the pixel factorized. Very well. It encodes all double entry information, and therefore all of Pacioli's double entry system within the bounds of 5 different layers of abstraction. This enables quantum states across a phase transition diagram to require only a very small training data set. We don't need to spend hours upon hours upon hours working exercises before we understand the model. By just working out, let's say, 20 exercises, you would be able to have a conversation with an accountant. You would be able to understand it. And that's what I mean when I say that it requires only a very small training data set. That's one of the expected benefits of such a wave function. Notice that the abstract to concrete nature of this tensor network creates a funnel effect, just like we saw on the abstract explanation. The funnel effect is what enables hyperfast computation, because it allows us to easily choose the right answer at every layer and eliminate the wrong ones, so we can quickly narrow down the right answer to the right answer at the last layer. To give a concrete example, if we know the answer to a problem is, say, link number 1, we would immediately also know the probable clusters and players that would come into play. The whole network works under this spooky action at a distance principle. Entanglement is revealed as we process each double entry by following 8 computable steps that make information digestible from input to output. Okay? So now that we have it in more concrete terms, think of it, let's say that it's an owner's contribution, right? So then that would mean that it is link number 1. Because it is link number 1, we would also know that, okay, first of all, we eliminate everything else. Everything else gets eliminated immediately. And because of that, we also eliminate all the rest here, and we know that the answer must lie between these clusters and these clusters. And we would also know that the answer must lie within these nodes and these nodes. It couldn't be anywhere else if the answer is link number 1. That's the benefit of that structured wave function or tensor network, right? Because it goes from abstract to concrete. So you get the abstract, and then you eliminate all the rest. Okay.
So on
Yes.
the third layer, if here you eliminate the rest, here, what are you trying to do that you're not trying to? It seems to be doing the same. Yes, these are layers and these are specific points, but does this compute anything which would eliminate a certain number of them so that it's other assets, short-term liabilities, rather than the whole galaxy of?
Yeah, that's a great question. So it just makes it easier to compute, because let's say that if it's an owner's contribution and it's going in, we are receiving that money into our cash account or cash and banks, then we know that that's a current asset. And then because we know it's a current asset, now here we would just search within current assets. So we're not searching within all the assets, but only within current assets. Yep, so it narrows down the possibilities, and that's what makes it so easy.
So the drawing on the third layer is not accurate on this?
It's not accurate. It is accurate if we just choose this one.
Yes.
But once you choose this one, then yeah, it would have to be just this one and just here. Yeah. I see you're paying close attention, and that's great. Okay, but yeah. Okay. Any other questions? Good. Okay, great. Good. Questions? No? Questions? No? Okay. All right. Can we see the financial Qbits algorithm in action? Yes, we can. Using the presented 12-body tensor network as a minimal complexity computational resource, we obtain hyperfast processing of financial statements. This translates to hyperfast financial literacy. And a good point for research is that we normally mention where we got that research from. So if the student wants to understand further, they can look into that research. Okay, so using the presented, okay. Let us follow the algorithm's 8 computable steps to process one double entry transaction and see it in action. So it is an owner's contribution for, let's say, 10,000 rupees, $10,000, 10,000 pounds, whatever. Let's just say 10,000 units of wealth. So we search the first hidden layer to define which of the 12 superposition double entries best describes this event. Because it is an owner's contribution, and of course, to answer this question, you would have gone through like 70% of the program. This is not something that you would answer at the beginning of the program. So because this is an owner's contribution, we know that it would be an outflow from funds, because owner contribution, well, capital stock is here, owner's equity. That would be an outflow from funds and an inflow into the assets. So that has to be link number 1. We search and we find link number 1. By doing so, we eliminate all the rest, and we begin to zero in what seems to be the right answer. Note, choosing link number 1 eliminates links 2 through 12. There. Funds goes into the assets. Define how much wealth is flowing from the sender's pocket, Alice, to the receiver's pocket, Bob. 10,000. Take the collected information from this layer to the next layer up. So it's picking up information. I like to think of it, I don't know if you're familiar with something called the Higgs boson. The Higgs boson picks up mass as it goes through the Higgs field. Here, the financial qubit picks up information, it gets informed as it goes through the financial qubits field. Does that make sense? Yeah, that's what it's about. It's going to pick up information as it goes along. So we take the information, take it to the next layer, and now we ask. We search. Search hidden layer 2 to define which of the clusters in funds is the sender and which of the clusters in assets is the receiver. Okay? Because it's an owner's contribution, we know that the cluster has to be owner's equity and in funds, and we know that in assets has to be current assets. So, you saw it, right? Yeah. So we choose owner's equity, and we choose current assets, and by doing so, this narrows down to just those possibilities, and so now it's easier to choose the right answer. Okay? All right. Take the collected information from this layer to the next layer up. Search hidden layer number 3 to define which specific account within owner's equity is the sender and which specific account within current assets is the receiver. All right, so that would be, can anyone, I don't know. Does anyone want to say which account is going to outflow from? No.
Let's analyze this, right?
Yes.
So the owner is making a contribution
Yes.
to the company.
That's right.
So there's two accounts involved. It's just bank and it's owner's equity. Bank will decrease, owner's equity will increase. So if you look at the accounting equation, A equals O plus L, right?
Well, it would outflow from owner's equity?
No, it would inflow because you're contributing towards the business, right?
No.
It wouldn't work like that.
It's coming out from the owner's pocket into the pocket of the business.
Yeah, so from the owner's pocket, wouldn't it come out from bank?
Well, that's from the businesses. To us, it wouldn't matter if he's taking it out from his bank, from his cash account. Yeah.
When you say the owner's equity, that's not the company's equity. It's the owner's equity putting into the company's equity.
No, I don't.
Yeah. Yeah. That's exactly right. So yeah. So it affects owner's equity, and it affects the company's cash and bank's account.
So my question is, why would I need to search through such a complex four-dimensional kind of thing when I know there's only two accounts affected? Intuitively, I know this as an expert system. I know it's two accounts. I'll just go through those two accounts.
Okay.
Sort it out.
Because you have that answer. But when you encounter a hard problem that you don't know the answer to, this helps you zero in and say, no, it can't be this one, it can't be this one, so it must be this one. This is like a super simple example.
Elimination.
Absolutely. Absolutely. And it's easier to eliminate at the macroscopic level than it is to eliminate at the microscopic level. So, but by eliminating at the macroscopic level, then it's easier to eliminate afterwards at the microscopic level. Make sense? Okay, great.
So,
Yes, sir.
obviously, the key to here are these layers, being able to define these layers.
Yes.
I'm guessing that using artificial intelligence and machine learning, could a system define the layers on its own, rather than us having to think, like you said your father did for so long in order to build these layers?
Well, if we were to build such a system, what we would do is we would feed the layers that we already know, because I think that would make it easier, because we already have the answers.
Yeah, if we know the layers, obviously.
Right.
If we don't,
That's a great question.
If we want to make it as more efficient layers, because we are uncertain. I'm just thinking if we don't have the layers. If we do, then by definition it's
Right, right. So in this case, we do have the layers, and we would go that route. But if we didn't have the layers, that's a question for Rani. That's a hard question?
Yeah. That's why I'm saying maybe machine learning, because by definition, machine learning, or how do you define a cat compared to a dog? We can't program that. But machine learning, they will do it by itself, which means that they should be able to layer
On its own, like you give it the accounts and the layers?
Yeah.
Okay. Okay, yeah. Okay, so number 6, search hidden layer 3 to define which specific accounts within owner's equity is the sender and which specific account within current assets is the receiver. So of course, like we were saying, it's capital stock in owner's equity and cash and banks in current assets. Take the collected information from this layer to the next layer up and populate the financial statements accordingly by doing this. We affect the accounts in capital stock, and we affect cash and banks by the amount of $10,000 and update the financial statements. Step number 8, repeat until all events from a given period have been processed. Yeah. And of course, at the beginning, this might seem a little hard, but once you take the program and you go through all of these layers and you understand the layers, it becomes second nature, especially when you do the algorithm part. It becomes like super easy, and you can solve like hard problems that you wouldn't think that you would solve so easily. You would think that it would take you at least a year to be able to solve that type of problem that only accountants could solve. Yeah. Did this make sense? Yep. Yep. Great. Okay. Does financial qubits upgrade the efficiency of current quantum computing approaches? I think so. I think so. And the reason why I think so is because we have a ground state wave function as first hidden layer of the algorithm search space, which provides the simplest possible search space configuration. Lower complexity, of course, equals less computational resources and faster processing speed, all else equal. Thanks to this, we just need 6 qubits and not hundreds or thousands. The reason why I say 6 and not 12 is because of superposition, these can be just 1 qubit, right? The 1 and the 2, and the 3 and the 4. And by the way, that's time reversibility, right? Because if you have a sale, this is a sales return. If you have a bank loan, this is the paying back of the bank loan. And they all have time reversibility. They work in that fashion. Yeah. Okay, so thanks to this, we just need 6 qubits and not hundreds or thousands to process an infinite number of probable double entry outcomes to recreate the story or the financial statements of any business at any given period of time. According to our research, there are very few practical applications of ground state wave functions in QML computing, and perhaps financial qubits might shed some light in this regard. Number 2, the Wheeler-DeWitt equation. It's a powerful concept with no previous practical application. The Wheeler-DeWitt equation, for those who are not aware, represents a time reversible wave function that maps not a particle but an entire universe. In this case, the universe is the set of combinatorial elements to recreate all real-world events that make up financial statements in real life. Number 3, small training data set and linear increase in complexity, not exponential. The abstract to concrete search space configuration allows us to understand the entire field with a very small training data set. With 20 exercises, you should be able to understand it. This saves resources like time, effort, money, hardware, etc. A purely pictorial system that is easier to process and learn for human and artificial brains. These 4 characteristics make financial qubits an exceptionally efficient algorithm that might help us enhance the current quantum computing modeling approaches. 3 common quantum questions answered. Number 1, what is financial qubits' quantum advantage? Well, just imagine this. If the search space, instead of being the search space we just looked at, was the traditional paradigm by Luca Pacioli, you would have to look into so many more concepts to answer each question, right? But with financial qubits, this is completely different. And another thing, like all classical systems, with the traditional paradigm, the harder a question gets, the more answers you would need to have answered, or the answer to. So let's say that it's just one double entry, maybe you just need those answers. If it's 2, you need that many more. If it's 3, it's that. And if it's 4, it's something like that. Just, that's just an example, but that's the idea. Using the old paradigm to build financial statements implies knocking on an ever-increasing number of doors, as problems to be solved increase in complexity. With financial qubits, optimal paths, you knock on a small and fixed number of doors to find any and all relevant answers, regardless of the complexity of the problem, in other words. This extreme reduction in complexity provides hyperfast computation. Okay. How is financial qubits a quantum algorithm? Processing data through a circuit based on quantum logic gates by following a set of computable steps is what is expected from a quantum algorithm. In fact, and this is what I understood from this article that I'm sharing there, in fact, being that the financial transactions on double entries belong to the classical world of 3D experience, financial qubits is the only tensor network algorithm capable of working in 3 dimensions. How many qubits does financial qubits have? And that's a little bit hard to answer, but in a way, they're infinite because this binary structure can be used to process an infinite number of probable double entry outcomes, and therefore infinite information. But at the same time, you could say that it just has one qubit, or one qubit, right, with a D, at the different layers of abstraction. Because it all boils down to just that particular shape, to that particular configuration, which is the double entry. Okay. All right, tensor network theory and deep learning postulates. Tensor network theory / quantum postulates. Number 1, pixelation / discreteness. Why? Because everything stems from this pixel, right? We can reconstruct the entire wave function just from that one pixel. Number 2, emergence. This here emerges from the interactions, from the microscopic interactions of the double entries. So we have emergence. Number 3, superposition of states. All of those states on the ground state that we're looking at, that's a superposition of states, Schrodinger's cat. Oops. Okay. Hold on. Sorry about that. I don't know why it went so fast. Superposition of states, time reversibility, entanglement. The whole structure is entangled, and that's why if we know the answer, it's link number 1, then we can eliminate the answers at the other layers. And operators. Deep learning postulates, meta-learning. I don't know if you're familiar with the concept of meta-learning, learning to learn. Concept encoding at different layers of abstraction, and information reuse. Note, financial qubits can also be mapped as a deep learning neural network. More details on the app that now you have access to freely for 1 month. You can go into the postulates, and it's going to give you a full-blown explanation as to each of the postulates. Okay, learning objectives, quantum literacy objectives, speak the language of quantum technology, understand the quantum wave function and the 6 postulates that make it work, tensor network. Learn how a wave function / tensor network can be used as a computational resource for hyper-fast computation. Grasp the deep learning postulates of meta-learning, information encoding at different layers of abstraction, and information reuse. financial literacy objectives, improve financial management skills, demystify financial statements, optimize relationship with accountants, and understand the philosophy behind systems like QuickBooks. It seems to me that QuickBooks is not really known in this part of the world, but it is. Is it known?
I use QuickBooks.
Oh,
Yeah.
all right, awesome. So yeah, it helps to demystify systems like QuickBooks. It's not a course on QuickBooks, but it's super helpful to understand the debits and the credits and the accounts, the chart of accounts, to be able to make sense of QuickBooks. Sometimes people do not record their information properly because they don't understand the chart of accounts. They don't understand the essence behind the chart of accounts. And not to mention the debits and the credits. I'm sorry?
I use QuickBooks. You should integrate this into QuickBooks.
Yeah, that would be great. Yeah. Yeah. Okay. Summary of this part. So this is, we're getting close to the end of the quantum presentation, and then we're going to go into the business presentation. Summary, time to grasp, the model from 1494, at least 1 year, financial qubits, 10 hours. Size of the model from 1494, 1 textbook versus 1 diagram. Encoding, text encoding versus shape encoding.
So the model size is more than 1 diagram, it's the layers.
Yeah.
So I would say it's more 3 diagrams now.
Well, it's really, so it is it's a complex diagram, but it's really 1 diagram, right? This is the panoramic aspect of the diagram.
Okay, so this is the real diagram.
Yeah, exactly, the detailed view of the diagram, but it's 1, yeah. Okay. Financial qubits, full quantum version at Vernival Academy. It is normally $550. Here at the conference, we have it for just $400. There's a $150 savings, just an FYI. Okay, we will go into the business part of it, and we're going to have another Q&A, but in case you have questions for this quantum part of the presentation, please feel free to ask. You're invited to ask and share away. No? Make sense?
I don't want to say yes or no. I want to go through it first, like, you know.
Okay.
Yeah.
You want to go through the app and take a look?
Yeah.
Yeah.
I'm just a skeptical person by nature, so I have to like go through it and
Absolutely.
deep dive. Yeah.
Absolutely. How about you, Hussein?
Yeah, I mean, I'm thinking like, as someone who's not from a finance background, someone from more like a physics, CS kind of background, I would say like it seems like a lot of the terms that you've used, it makes it interesting to understand like the basics of financial accounting and how all this works. But as for the how realistic it is to what these terms actually mean, the quantum terms, you know, quantization or whatever concepts you're talking about, those are quite far-fetched from the reality of what it actually is. And I feel like, you know, people might just be caught up in thinking of like, hey, you know, these terms aren't accurate, so why should I believe, you know, anything that the course is saying? But I sort of see that you're using these terms in a way to really explain the concepts, and it's quite intuitive to me as someone who has this previous knowledge, but I do see that the terms, like, they don't match up with what they actually mean. But some people might just take this a bit too seriously. That's sort of a thought that I have.
Okay, but if it's quantized, wouldn't it mean that you can describe the entire wave function with just 1 particle, and that you can like recreate the wave function from 1 bit, from 1? Wouldn't that be quantized?
No, that's not what quantization is.
No.
Quantization is when you take two disparate operators
Okay.
and you try to show that there's a minimum that you can get that comes out. Usually that's the Planck constant and the imaginary number I. So that's quantization.
Okay.
And a whirl line is like a pathway through space-time. And those 2 manifolds, or those 2 layers that you drew, they call manifolds. And that connector between the 2 that you drew going up, that's called the Einstein-Rosen bridge. It's like a connection between space-time.
Uh-huh.
So I was just thinking to myself, like, you know, how did you like come up with these very, very advanced concepts in theoretical physics and put it into finance?
Okay.
Yeah, so that's why my skepticism sort of waned in, you know, so I have to
look at it more and try to make sense of the jargon and what you're trying to portray, you know?
Yeah, perhaps there are certain concepts that are being used too loosely.
Like if you submit this, I promise you, if you submit this work to physical review, you will get a backlash from people they'll make YouTube videos about you. That's what I can say.
I see, okay.
Like there's this guy, Eric Weinstein. I don't know if you heard of him.
What's his name?
Eric Weinstein.
No.
Very famous on YouTube.
Okay.
Very smart guy. But it's just how the scientific community is. You know, they troll him, and so yeah. I just want to look at it more in depth. So I know a bit of finance, like a little bit of accounting, but more on the derivative side.
Okay.
I know a lot about physics. So yeah, I think just have to make sense of it.
It seems a lot more on the quantum side of things. Financial qubit seems a lot more creative in its form of explanation and how intuitive it is. I consider it to be more of a qualitative explanation of how you're understanding these different concepts, but I wouldn't say that the quantum aspect of it is sort of realistic or accurate to what the terms actually mean in the world of physics or mathematics, or when you actually go down that entire route. So that's just sort of a gripe, you could say, that I have. But generally, like what you're teaching in terms of financial accounting, like of course I want to go through the course and see it's only a small part. Like what I'm understanding so far, like of course this is much better than studying a regular textbook like this, and maybe I'm sure this has a lot of other information that wouldn't be covered here in the course, but who needs that extra information for someone who's just a business owner who isn't even doing the accounts themselves, and how complex do you really want to get yourself?
Yeah, yeah, no, absolutely. And perhaps we could do like a disclaimer or something, or fine-tuning the concepts so that they do match the actual quantum concepts, like what you were sharing.
Yeah.
Yeah, okay.
I think from my side, so I am not a scientist, so I'm not even an engineer. The first thing we have to recognize is there is immense difficulty in understanding financial concepts. That's why there are whole courses and you become an accountant. So by definition, just like you guys are scientists, I'm assuming an accountant, if somebody has found a way to make it so much simpler to understand accounts, there's got to be something in the fact that one is able to translate a complex, chaotic model into something that is easy to understand. So for me, that process is mind-boggling as to how you've been able to do so. And it's great because I work in finance, and even the time spent on the questions that you ask, I would have had to do this properly other than just kindly and read on. And I'm supposed to know this, and I oversee risk people in finance.
Yeah, but you have your search space is too big.
It's too big. It's too big. So
exactly, unless it's something you're doing on an everyday basis.
So for me, when I look at very complex, chaotic models where basically everything has let's say Excel cell has a link to another one, being able to find a summary, which is what your layers are, would be of immense practicality. I'm just thinking, just because I did some course in large language models, not because I'm an expert, large language models need so much computing power because every single unit has to be tested against the entire universe of every other single unit of language. And it builds a statistical model and links between the two. So you have a massively chaotic and complex system, which is why we're talking about billions of units if you look at your ChatGPTs, 3.5 and 4 and all that, and how big this is. Mm-hmm. And the computational power required to run these large language models is exponentially, crazily big, let alone the energy required, by the way. So if and these models exist in many, many spheres, not only language, but other spheres. So my number one question, which is why I was focusing, is how do you build these intermediate layers to make sense? So I'm just thinking out aloud. In language, we have verbs, adjectives, nouns. If you start building this, then you can much more quickly link things or eliminate things by having very, very simplistic layering, which eventually gets to be more complex. But without a large language model specialist, I would have no idea if what I'm saying makes sense. But I can intuitively or gut feel see why they've always been saying that AI and quantum can work hand in hand rather than a classic computer, which would have to do the book way of doing things. But that's up to you guys.
Yeah, absolutely.
I think that's the old way of like how language models used to work with statistical models. Now they use this thing called the attention mechanism, where they don't have to search the whole entire universe of what they have. They sort of use probability to narrow down what they think it is, and then they associate.
But that probability comes from learning.
The weights.
Yes, the weights.
Yeah.
And this training comes from doing it the classic way. It's just that once you weight the model, then you can do these things.
But the quantum way of training, they call it parameterized quantum circuit. It's exactly the same. It's like you have weights, you try to learn the optimal weights by minimizing something, right? So it's the exact same.
But if you can put intermediate layers where you make it fuzzier to make it more quick, could quantum speed things up compared to a classic computer?
No, not in all tasks. You see, that's the thing about quantum. It's only certain tasks. It's not everything. Like people have this, like it's the magic.
For everything.
Yeah, it's not. It's not.
No.
Nobody claimed that. Like the founders, Feynman never claimed this. It's like the people who hype it up and know all the buzzwords.
I'm asking. I'm not saying.
Yeah. I'm saying like they give the wrong impression about the field. It's not. It's to solve certain classes of problems. Yeah. So.
Okay.
It's not everything. Like I think. Yeah.
Okay. All right. Let's go into the business aspect of the presentation. Great.
Thank you for the presentation, but I'm going to have to leave.
You leave? Okay.
Thank you so much.
Oh, my pleasure. Thank you for coming.
Thank you. I also have to.
Okay. Do you think we're going to be able to meet tomorrow?
Of course, hopefully. Otherwise, we can have an online meeting. It should work.
Okay, but do you know about how your schedule is going to be tomorrow?
Yeah, I can inform by about 7 p.m. tonight. I can just confirm.
Awesome. We can
have another
text.
Physical meeting in Abu Dhabi.
Absolutely.
Thank you.
Have a good one. All right, let's go for the business aspect. Financial qubits for the business world. How does financial qubits work? Is it an app? Yes, it is a web app. So we have the visual syllabus, and financial qubits is available 100% online as an interactive web application hosted by a learning management system. And it is learned in 2 parts. In part 1, you learn the new map, its players and its relations. In part 2, you will learn how to use the new map to build financial statements hyperfast, 1 building block at a time. Once you have built them, you will learn how to analyze financial statements to help a business succeed. Part 1 is learned by watching 4 video lectures and completing 5 self-grading quizzes. Part 2 is learned by watching 1 video lecture and completing an interactive case study. To conclude, a self-grading final exam is administered, and grades 80% and above obtain a certificate of successful completion. All-in-one multi-platform learning management system. Okay, learning objectives, improve financial management skills, understand the philosophy behind systems like QuickBooks, optimize relationship with accountants, and demystify financial statements, all in 10 hours. And with a true understanding, right? Because sometimes I've had 30-year, 4-year accounting students, and when they see this, it opens their mind, and they realize that they had blind spots that now are covered. Why is it important to understand financial statements? As I was sharing before, financial statements tell us the story of a business, and understanding the story can help a business grow and succeed. This is because it can help us determine what to do to improve in the future. The problem, financial statements are written in a foreign language, and it can take textbooks worth of information to understand. The story is in a complex and sophisticated language that is extremely difficult for most of us to interpret. To top it all off, it comes from the year 1494, the model to understand it. And like most things from antiquity, Pacioli's scheme is extremely complex. Okay? It can take more than one textbook and at least 1 year to understand this language with confidence. So what if I don't speak the language, you might ask? Well, poor financial management can drive a business to bankruptcy. Poor use of systems like QuickBooks, without effective use of powerful tools, competition can drive us out of the market. Costly divorce with accountants, valuable advice left on the table, unable to monitor their work, and low probability of obtaining business loans because the bank is going to want to know, are your books in order? Can you tell the story of your business in financial terms and tell me your plans in financial terms that make sense? Are we doomed to have such high levels of financial illiteracy in the entrepreneurial community? Or is there a magical, condensed, and visual way that would make it fun to learn and save time, effort, and money? Yes, of course. It begins with a simplified and visual understanding of entrepreneurship. I like that phrase by Leonardo da Vinci, simplicity is the ultimate sophistication. People think sometimes that the more complex something is, the more sophisticated it is. I disagree. So what is entrepreneurship? What is entrepreneurship from a financial standpoint? Well, at least one aspect. How could we draw it in its simplest form? Well, I don't know if you watched the movie called In Time. It refers to standards of living in terms of time zones. So if you're wealthy, you have a lot of time. And they say, oh, he comes from time. And so they express it in terms of time zones, and we can think of the north being wealthier, the higher the time zone, and going down south, that would imply more poverty. More poverty means more uncertainty, and going north normally implies less uncertainty. And if you're an entrepreneur, you normally want to go from A, a lower time zone, to B, a higher time zone. It's not only about the money, but that's normally part of the idea of entrepreneurship. You want to be in a better time zone. So we have A, we have B, and we have C. The best path to get from A to B. The best string of events that will conceivably take us from A to B. Okay, but how should we measure progress from A to B? Okay, so it reads, typically part of the idea behind entrepreneurship is living in a better time zone. If so, how should we measure growth, in other words, progress in financial terms? Should we measure it in terms of sales, net profit, or something else? Anyone?
Okay, now here I can use one of the interesting frameworks that used in the business world called balanced scorecard.
Okay.
Yeah, which says that the performance of a company should be measured using 4 parameters: financial, customer satisfaction. We call it as financial perspective, customer perspective, then process perspective, and finally the people and innovation perspective. So the idea is, if you want to achieve financial performance, you need to have a good number of customers
Happy.
satisfied.
Oh, yes.
If you want to keep a good number of customers satisfied, you need to have robust processes, which makes them happier. And if you want to have good robust processes, you need to continuously innovate. And then underlying factor is the people factor. So when the people are,
I totally,
people,
I'm sorry.
good process leads to good customer satisfaction. Customer satisfaction leads to financial. So the underlying fact is, don't measure your business only based on financial parameters, because sometimes it is good, but the underlying things are weak. So temporarily you are seen as successful.
But in the long run,
your base is not very.
yeah, I totally agree. But just like in a snapshot, if it were one of those three things, sales, net profit, or something else, we're only talking about just going from time zone A to time zone B. What would we need? Sales, net profit, or is it something else?
Well, we need net profit if the only thing we measure is our financial performance, because we want to become wealthier, but we need the profits.
Okay.
That's just in a simple model, yeah?
Right. Yeah, it is necessary to have the customer satisfied, because otherwise they're not going to buy from you in the long run. Totally, yeah, okay. So what we are trying to convey with this message is that you can have, like a company can have tons and tons and tons of net profit and not necessarily be generating any cash. Right? And if you're not generating cash, then you're not going to be able to make it from time zone A to time zone B. So part of what we're trying to point out is that they say that net profits are the bottom line. Not true. The cash flow you generate is the true bottom line. The problem is that it's so hard to figure out how to realize how much actual cash the business is generating that they just leave it at the net profit. But the story doesn't end there. That's the point that I was trying to make. So there. And why? Because all of the bills, the mortgage, all of the bills are paid with cash. If you want to pay the light bill with profit, they're going to tell you no. Yeah, that's the point that I was trying to make. And so cash flow, why? Okay, well, just went through that. So we can think of financial management as investing or risking wealth into the business, and we want to squeeze out two things: profits, which are potential dollars, and cash flow, which are real dollars. I like to think of this in the most respectful way, but like the work of Moses, because it's about knowing how to split the waters, right? Knowing how to split the profits from the cash flow. An often overlooked key focal point, right? What is the first step to improve financial management? I'll go kind of quick because I think we're running out of time. What is a debit? What is a credit? Even if you ask an accountant, what is a debit? They will normally say that a debit is that it depends on the nature of the account that you're affecting. And what is a credit? It depends on the nature of the account that you're affecting, but they can't tell you what exactly it is, if it's an addition or if it's a subtraction. And sometimes, even if they tell you it's an addition and a credit is a subtraction, they often cannot tell you why or explain how it works. Okay? Well, all right. Let's go on. So let's dive in. The four main accounts. So we have funds, assets, sales, and expenses. Funds, assets, sales, and expenses. If the company spoke, it would reveal to us the essence of each of the quadrants. So about funds, it would say sources of my wealth. About assets, it would say my wealth. About sales, it would say my wealth generation, because that's how you generate wealth. And about expenses, it would say my consumed wealth, the ashes, right? The wealth that becomes ashes. Those are the expenses. Everything stems from these four main players and their interactions. At this panoramic level, it's extremely simple. We just have those four main players. This is our glimpse of the panoramic level of the four fundamental accounts. Sorry. Now we are going to divide each quadrant into three sectors for a glimpse of the detailed level of the chart of accounts. The chart of accounts is the catalog of players that make up the financial statements of a business. Mastering the chart of accounts will help us make better sense of systems like QuickBooks. For this, we're going to learn the sectors, their essence, and the specific players or accounts that fit within each quadrant. Okay? Three sectors of each quadrant: funds, and it's three sectors. About funds, the company would say sources of my wealth, and we have the sectors of owner's equity, long-term liabilities, short-term liabilities. Essence of each of the three sectors: Owner's equity, owner's invested wealth. Long-term liabilities, debt due beyond the next 12-month period, and the key word is beyond. Short-term liabilities, debt due within the next 12-month period. Which actors fit on this quadrant? In owner's equity, we have capital stock and retained earnings. These are, of course, example. A company can have more, etc. Long-term liabilities, let's say bank loans that are due in the long term. Short-term liabilities, we have accounts payable, supplier credit, bank loans in the short term, due in the short term, taxes payable, miscellaneous provisions, interest payable, commissions payable, dividends payable. Okay. What is the identity of these actors? So in owner's equity, we have capital stock, wealth contributions made by the business's owners in exchange for shares or stock of the business. Retained earnings, reinvested wealth. Earnings reinvested in the business as opposed to being paid out as dividends. This investment belongs to the business's owners. Long-term liabilities, bank loans due in the long term. Debt with financial institutions due in the long term, that is more than a year. Short-term liabilities, accounts payable, supplier credit, debt the business has acquired with its suppliers through credit purchases. Bank loans due in the short term, debt with financial institutions that are due in the short term, in other words, within a year. Taxes payable, debt the company has with the government for unpaid taxes and miscellaneous provisions, various debt or liabilities created for expenses incurred but not yet paid. Okay. Interest payable, interest that were not paid when due and become short-term debt. Commissions payable, debt the business has with its salespersons for commissions that the salespersons have earned but haven't yet received. And dividends payable, debt the business has with its owners when it has been declared that dividends will be paid out normally within a year. Okay. Profits are reinvested in the business as retained earnings, or they are paid out to owners as dividends. So the owners of the business make their investment, make their bet, the wealth comes back out if everything goes well. And there's the decision, do we leave it within retained earnings or do we pay out dividends? There. Okay, profits are reinvested in the business, okay. This is super important, right? Liabilities, obligations, line of payments. So, more immediate, less immediate. So the closer we get to the tip of the, let's say, pyramid, the less time we have to pay that type of liability. The farther we get, the less immediate or the more time we have to pay it. That's why we have short-term liabilities on top, long-term liabilities in the middle, and owner's equity all the way at the bottom. Debt expiration, due time, undefined, more than 1 year, within a year. Financial source type, internal sources equal owners' investments, external sources, liabilities or debt. Okay, those are the players. Any questions? Makes sense, right? I mean, okay. Assets, I'm not going to go into each one, but you know, you get the idea on the app. Of course, the video goes into each one, and then with the quizzes, you practice each one. Those are the players, sales and its players, expenses and its players. Okay. Let's not lose the panoramic view. The business scenario can be condensed to its four main actors. So all of the players here are just funds. All of the players there are just assets. The players there are just sales, and all of those players are expenses. Okay? Now we're going to look into financial qubits. The global transit, which is about the relations that connect the players. These are the double entries, right? So let's take a look at the actual financial events that make up financial stories and therefore financial statements. This will demystify the debits and the credits ordeal for good, and it will help us understand how financial transactions are recorded in systems like QuickBooks. So,
So this presentation is part of the program, right?
absolutely.
It is there in the
Yes, 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 yes. In its entirety, yes. What the part that we're seeing, yes. Owner opening event, owner's investment for 3,000. Which quadrants come into play? Anyone?
Owning investment, what's for what?
Owners, 3,000 units of wealth.
Oh, okay. Yeah, I mean, it's the gold one.
All right, so funds
Going into the green one.
into the assets, right? So funds and assets. What is the orientation of the flow of wealth? So it's coming out from funds and it's going into the assets. How much is flowing? Not a trick question, 3,000. And the $64,000 question, how does this flow affect the accounts of this event? So the question is, what's going to be the new balance in funds and what's going to be the new balance in the assets? In pure math, without thinking about the debits and the credits, in pure math, what's going to be the new balance in funds and what's going to be the new balance in assets? Can anyone tell me?
Well, it goes, I mean, you have 3,000 in funds, it goes to 0, and you have assets going from 0 to 3,000. Obviously, from an accounting viewpoint, you have to have the reverse as well to match.
Right, yeah. So what would be the balance?
The net 0 would be on an accounting basis, because you're just shifting.
Right, but
Plus 3,000 minus 3,000.
exactly. And that's what I was looking for. Because it's an outflow, and outflows are subtractions, and inflows are additions, this would have to happen. Funds, 0 minus 3,000 equals minus 2,000. The assets, they were at 0, plus 3,000, plus 3,000. There's not two ways about it, right? Observation, assets, the normal balance of assets ranges between 0 and positive infinity. And the normal balance of funds ranges between 0 and negative infinity, the normal balance. Okay? Observation funds is counterintuitive, of course, because as wealth outflow from funds, it increased, right? That's so we can record that the owners have more of a stake in the business, right? Like they own more of the business. Counterintuitive. Okay. Accounting equation. Yeah. Okay. So we can see it dynamically. Wealth outflows from funds. It goes into the assets. Funds increases and assets increase as well. Funds increase, assets increase. Okay. Those form, of course, a mirror image, like what you were saying, because we have negative 3,000 in funds and we have plus 3,000 in the assets. That's the assets equal funds. It's a shortened version of the accounting equation. Okay, event sale for $1,200. Which quadrants come into play in this event?
The sale is removed on the left.
Yep. So sales and who else?
But you have expenses for sales.
Let's say it's a service sale.
Okay. So it's plus 1,200. But you'll still have expenses, okay, for the time and all that. So you will have.
Yeah, but you wouldn't record it on that interaction.
No, okay.
Yeah. So what other quadrant comes into play? The assets. Yeah, because wealth would outflow from the customer's pocket and it will go into the assets. And we're going to wrap it up just because in the interest of time. So how does this flow affect the accounts of this event? So what would be the new balance in the assets? The assets would be 3,000 plus 1,200, 1,200. And what would be the new balance in sales?
Well, it's you have But I mean, if you move, you should have minus 1,200.
That's right. That's it.
Because you've moved, yeah.
That's it. Yeah. It's a little strange, but yeah, that's the only way to make sense of it. Okay, let's wrap it up. Just to get to the end of this. So is this making sense? Intuitive, right? Yeah. The whole course is super intuitive. Everything is visual, so everyone can understand and relate to it. We can boil down everything to just saying we have two types of accounts: positive accounts, which are at the right-hand side, assets and expenses, and at the left-hand side we have funds and we have sales. And this solves the debits and the credits ordeal because positive accounts are debit accounts. They increase with debits, which are additions, and decrease with credits, which are subtractions. Negative accounts equal credit accounts, increase with credits and decrease with debits. The quiz is demystify all of this, right? So that's it. That's the global transit. Whenever we see that relation, number one, owner's investment and acquiring debt. Number two is paying back. Number three is sales. 4, sales returns. 5, expenses. 6, reversal of expenses. And then we would do 7, 8, 9, 10, 11, 12. And that would give us pretty much a complete picture of anything that can happen. From the most panoramic level to the detailed level of the chart of accounts. We gain full understanding of the double entry accounting system, all within the bounds of a simple map that is easy, quick, and fun to learn. So what if I understand the new map? What's the benefit of this? If it maps the panoramic view of the two fundamental financial statements, the income statement, which is sales and expenses, and the balance sheet, assets and funds. Well, if you had more time, we would go into the actual program, but we don't. Therefore, by understanding the new map, we can build financial statements from scratch, one building block at a time, to understand them and analyze them, to extract the story of a business for growth and success. Final word, financial qubits should come as no surprise. After all, quantum effects are expected to be found at the base of all reality. This is great news for the quantum community and along with other great tools. It should help us prevent a quantum winter. Given financial qubits' applicability to the financial and quantum worlds, it is not just poised to greatly benefit the economy for upgrading the 500-year financial paradigm, but it is also an important victory for the ongoing second quantum revolution. Special offer, there's a special offer, but you know, we can speak later. Benefit for the business world, okay, all right. That's it.